Hello dear students, welcome to this YouTube channel. Today we are going to do the very most important numericals of solution chapter. So here I have divided the two parts. In this session we are going to learn the numericals on concentration terms, and in the part 2, in that we are going to learn the numericals on colligative properties. So both of these are going to be very important for your board exam, KCET, NEET and all the competitive exams. So make sure you are going to watch a complete video. Okay, so let's get started. So here we have a mass percentage, a problem on mass percentage. So let's see what is the question. What is the mass percentage of solution of 3.6 gram of sucrose in 83.4 gram of water? So they have given two values for us, that is 3.6 gram and 83.4 gram. This is for sucrose and this is for water. They asked us mass percentage. So we know that what is given. So whenever you solve any problem, first write down the given part and see what we need to find out. So the given part here is 2, that is mass. Mass is expressed in W, mass of solute. Here the solute is sucrose, right? Whenever in the solution, particularly in this solution chapter, in every problem you need to find out what is solute given and what is solvent. Okay, so here sucrose is solute and water is solvent. So mass of sucrose, here is 3.6 gram and mass of water is 83.4 gram. Right. So now we'll see the formula, mass percentage of solution. So mass of the solute divided by total mass of solution into 100. So this is a formula, right? Mass of solute, that is mass of sucrose, so that is 33.6, and total mass of solution. So what we have to do? We have to add this both, because solution is a mixture of solute and solvent, right? So if I want to find out the mass of solution, I have to add up all the both, means I have to add the mass of solute and mass of solvent. So I'm going to add this both, 3.6 plus 83.4. So if I add this and multiply this with 100, I'm going to get the value. I'm going to get the answer for this particular question. So this is going to be around 8.4%. Okay, so this is the value for mass percentage of solute. This is mass percentage of solute. Similarly, we can find out the mass percentage of solvent. Here they have not mentioned the mass percentage of solute or solvent. They generally have told mass percentage of solution. It means you have to find out for both. Okay, mass percentage of solute, and similarly we need to find out the mass percentage of solvent. Okay, the same way, mass percentage of solvent. To find out mass percentage of solvent, what we have to do? We have to take mass of solvent divided by total mass of solution. So mass of solvent is 83.4 divided by total mass, this is the same, 3.6 plus 83.4. and if you solve this, you are going to get the value. Simple. Okay. Now let us move on to the next question. Calculate mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of CCl4. I'll change the color. So here they have asked what is the mass percentage of benzene C6H6 and also mass percentage of carbon tetrachloride. We need to find out both the value. If 22 gram of benzene, so what is the mass of benzene? Mass of benzene is 22 gram. Is dissolved in 122 gram of CCl4. So mass of CCl4 is 122 gram. Okay, we have written the given data and what do we need to find out? So first we find out the mass percentage of benzene. So we know that whenever we need to find out mass percentage of any component, we have to take the mass of that component. It means mass of C6H6 divided by total mass of solution into 100. This is the formula, right? So mass of C6H6, what is mass? This is the mass 22 divided by total mass of solution. It means we have to add this both. So what we have to do, 22 plus 122 and whole into 100, and we need to solve this. And if we solve this, we are going to get the value equals to 84.72%. Okay. Similarly, we can find out the mass percentage of CCl4. So mass of CCl4 divided by total mass of solution. So mass of CCl4 here is 122 divided by total mass of solution. It means we have to take both mass of solute plus mass of solvent. And if we take this, we are going to get the value around here actually mass of benzene, we got the value equals to 15. Not this. This is the value for this, and for this here we are going to get the value 15.28%. Okay, and if we solve this, we are going to get 84.72%. Okay, simple, a very simple question. So if you know the formula, then you can easily substitute and find out it. Okay. Now comes volume percentage. So what is volume percentage? We'll see that. Volume percentage means volume percentage of component. We have a formula like this. Volume percentage means it is denoted by V by V. So in the numerator and denominator we have volume only. So volume of component divided by total volume of solution into 100. Okay, so what is the volume of component? Volume of component means if you want to find out the volume of solute, then here we have to take volume of solute and total volume of solution into 100. And similarly, if I want to know the volume percentage of solvent, then volume of solvent divided by total volume of solution into 100. This is the formula. Okay, so I'll rub it out and So now we'll solve this question. The antifreeze solution consists of 35% by volume, 35% by volume of ethylene glycol in water. Calculate the volume of ethylene glycol present in 250 ml of this solution. So this is the question they have asked. I'll increase nipple thickness. So what we need to find out? Volume of ethylene glycol is you need to find. Present in 250 ml of the solution means volume of solution is given. What is that? 250 ml. Okay. So one more thing they have given, that is 35% by volume of ethylene. So volume percentage of ethylene glycol is also given, that is 35%. So what do we need to find out? Volume of ethylene glycol. So we'll see the formula first. Volume percentage of, consider if we are finding for ethylene glycol only. So as we know that if this is a component, then volume of ethylene glycol is taken here divided by total volume of solution into 100. So this value is already given, 35 equals volume of ethylene glycol. We need to find out. So we will put it as X. Okay. Total volume of solution that is also given 250 into 100. And if we solve this, X is equal to 35 into 250 divided by 100. We are going to get the value. What is the value? That is 87.5 ml. This is the volume of ethylene glycol. Very simple question. If you know the formula and if you know to write the given and what do we need to find out, then it is very easy for you to find out this. Okay. Now let's move on to the next question. That is on mass by volume percentage. So you may ask, what is mass by volume percentage? Mass by volume percentage indicates mass of solute divided by volume of solution into 100. Simple. This is a formula. Mass of solute by volume percentage, volume of solution into 100. So let us see the question. The saline solution NaCl in water is W by V. It is represented by W by V. That is, this value is already given. Okay. How many grams of NaCl is required to prepare 35 ml of the solution? So the volume of the solution given is, volume of solution is given as 35 ml. And they have asked how many grams, means weight we need to find out. Weight of NaCl, that is weight of solute, right? Mass of solute we have to find out. So this is something we need to find out. This is given, and we can easily solve them. Okay. So first thing, write down the given. What is given? Mass by volume percentage is equal to 35. Not 35, sorry, 0.92. Okay, 0.92. And then we need to find W of solute. And volume of solution is given as, what is the volume of solution? 35 ml. So simply we are going to substitute here. Percentage is 0.92 equals X divided by 35 into 100. And simply if we solve this, x is equal to 0.92 into 35 divided by 100. If we solve this, we are going to get the value in terms of grams. Simple, very simple. The thing is, you need to know the given data. Okay, the data you have to know properly. If you know the data properly, you can find out the answer easily. Now let us move on to the next part. The question is on mole fraction. So what is mole fraction? Mole fraction is denoted by x. So mole fraction means, generally consider I have a cake, okay, and I am going to cut it into half. So what is the fraction? This is half and this is half. Why did I call it as half? Because in one part I made two equal halves. In one part I made two equal halves. Clear? So this is a fraction. Generally, mole fraction for two components. Consider I want to find out a mole fraction for a component. So I have a formula like this: Na divided by Na plus Nb. So what is Na? Na is number of moles of a component divided by total number of moles of all the components. Okay, total number of moles of all the components. Okay, so this is a formula. So let us see. You got to know what is mole fraction now, right? So if I want to find out the mole fraction for any other component, then Nb divided by Na plus Nb. So in this case, I have considered a solution is binary. Binary means only two component is there. That is A and B component. Only A and B components are there. So I considered it as a Na and B. Okay. So generally we have a formula: number of moles of a component divided by total number of moles of all the components gives me the mole fraction. So let us see how we can solve this particular problem. Now, a solution is prepared by dissolving 1.2 gram of urea in 36 gram of water. Calculate mole fraction of urea in water. So, what is the given here? Given data is 1.2 gram. So, generally one trick I would like to give: solute is what which present in lower quantity, means small quantity. So wherever you find a smaller number in terms of gram, you can consider it as W of solute. Mass of solute you can consider. This as mass of solvent. It is mass of water. Solvent. Okay. So here W solute is 1.2 gram. W of solvent is 36 gram. So now I need to find out mole fraction of urea. So here I have urea. Solute is urea here, NH2 CONH2, and solvent is water. So here I want to find out mole fraction of urea. So what is the formula? Mole fraction of urea, it means that is solute, right? Mole fraction of urea, that is solute. So N, number of moles of urea, divided by number of moles of urea plus number of moles of water. This is the formula. So what is the value of N? Number of moles in the question they have not given. The moles they have not given, but they have given the weight, right? So N is mass by molar mass. Mass by molar mass. So number of moles of urea is equal to mass of urea divided by molar mass of urea. Correct? So mass of urea is already given here. But what about molar mass? Molar mass they have not given. So now we need to find out the number of moles of urea first. So mass is this one, 1.2 gram, molar mass of urea. So molar mass, how do we find out the molar mass? Okay, we'll see the molar mass here. Nitrogen, 2 nitrogen is there, 2 into 14 plus 4 hydrogens are there, so 4 into 1 plus carbon only 1 plus oxygen 16. So if we solve, we are going to get the value. So if we solve this, we are going to get the value for this as 60 gram per mole. Okay, gram per mole. Similarly, if we want to find out the molar mass of solvent, molar mass of water, is in the water we know that 2 hydrogens are there plus 1 oxygen. So 80. Okay. So number of moles of urea I want to find out. Mass by molar mass. Molar mass for urea here 60. Similarly, number of moles of water. So number of moles again. Mass of water. What is the mass of water here? 36. Molar mass of water, that is 80. Okay. So now I got to know the number of moles of urea and number of moles of water. Now I can easily substitute this value here. We can substitute, right? So if we substitute number of moles of urea, if you need to solve this properly. Okay. So if we solve, at last the mole fraction of urea, you are going to get the numerator is 0.02 divided by 2.02. You will get the value equals to 0.0099. So mole fraction doesn't have a unit, so you can write as it is. Okay. So but generally wherever you have concentration terms, it is important for you to write down the unit. Even unit carries some marks. Okay. So now let's move on to the next question. Right. Calculate mole fraction of benzene in a solution containing 30% by mass of CCl4. So what do we need to find out? Mole fraction of benzene. So we know that we have a formula. What is that? Mole fraction of benzene has a formula like this. Number of moles of C6H6 divided by number of moles of C6H6 plus number of moles of another component is CCl4, right? CCl4. So this is the formula. But number of moles they have not given, but I have a form. In place of number of moles, I can able to write mass by molar mass, right? Mass by molar mass. So this formula is going to change as mass of benzene divided by molar mass of benzene, then mass of benzene divided by molar mass of benzene plus mass of CCl4 divided by molar mass of CCl4. So here just in place of number of moles I have put it as mass by molar mass, right? So we have to see, do we have all the values for this? No. Weight of C6H6 is given? No, they have not given it directly. The given data. So this is also again a formula. So given data we must know. Given data is 30% by mass of CCl4. It means 30 gram of CCl4 plus dash gram of, what is that, benzene gives me 100 gram of solution. Okay, it gives me 100 gram of solution. So this is the mass of solution. This is, I need to subtract, right? 100 minus 30. So that is 70. 70 gram of benzene. 70 gram of benzene, it means this is weight, mass of benzene. This is mass of benzene. This is mass of CCl4. So now I can easily substitute here. Mass of benzene, mass of CCl4. So what about molar mass? So I need to find out molar mass, right? Now I will find out molar mass of benzene. So here I have 6 carbon into. Molar mass can be calculated by adding the sum of the atomic masses present in that particular compound. So here 6 carbons are there. So 6 into carbon, atomic mass is 12, plus 6 hydrogen, atomic mass of hydrogen is 1. So we solve this, we used to get the value of molar mass of benzene. So here we got a molar mass of benzene as 78 gram. Similarly, molar mass of CCl4. So carbon is 12 plus chlorine is 4 chlorine is there, so 35. Each chlorine atomic mass is 35.5. So if we solve this, we are going to have the value equals to 15.4 gram per mole. So now I got the molar mass also. So by substituting all this value, I am going to get the value. Simply you need to show that you are substituting all this value. Okay. Molar mass of benzene 78. Similarly 70 divided by 78 plus weight of CCl4, where is the weight of CCl4? 30. Molar mass of CCl4, that is 15. And what we have to do, we have to solve this all 0.821. So this is the final answer. Mole fraction of benzene. Simple. So now we will move on to the next problem, molarity. On molarity. Calculate the molarity of solution containing 5 gram of NaOH in 450 ml of solution. So what do we need to find out here? Molarity. And they have given 5 gram of NaOH in 450 ml of solution. It means 5 grams. This is the weight of solute, weight of NaOH. Correct. So the mass they have given, weight of NaOH. Or generally, as I told, whenever solute comes, we used to indicate by 2 number and solvent by number 1. Okay. If it is a mass of solute, it is W2, and if it is a mass of solvent, it is W1. So do remember that. And if we speak about number of moles, N2. If we speak about number of moles of solvent, N1. So this is the thing. So what is this then? Mass of solute. So mass of solute, it is W2. So what is given? 5 gram. Okay. Then 450 ml of solution. So ml, it means it is a volume of solution. So V of solution, it is 450 ml. Okay. So let us see the formula. Molarity is number of moles of solute divided by volume of solution in liter. Volume of solution in liter. So N can be written as mass by molar mass. Mass of solute divided by molar mass of solute into volume of solution. If it is given in ml, what we have to do? We have to divide by 1000. So if we divide here, we will take it to the numerator side, right? So if we substitute now W2 5 gram, M2, where is M2? M2 is the molar mass of NaOH. We can find out that, right? M2 can be find out as this is the molar mass or molecular mass of NaOH. So what is the molecular mass of NaOH? Sodium 23, oxygen 16, hydrogen 1. So if we solve this, we are going to get the value 40 grams per mole. So we are going to write this one here, 40 into 1000 divided by volume, 450. And simply we have to solve this, and after solving, the value is 0.278 molar, or the unit can be written as mole per liter. Okay, so unit is very important. Unit is very important. I am stressing this multiple times because even you are going to have a marks for the unit. If you write the unit, you are going to get the marks, and if you don't, you are going to lose the marks. Fine. Now the next question, calculate the amount of benzoic acid required for preparing 250 ml of 0.15 molar solution of methanol. Calculate the amount of benzoic acid. Amount of benzoic acid means what we need to find out? W of benzoic acid. So here benzoic acid is a solute, right? So W2 here is, we need to find out, right? Required for preparing 250 ml of. So volume of solution given as 250 ml. And what is this? This is molarity. Molarity is also given. Molarity is given as 0.15 molar. So we have written the given data. In methanol they have told, it means this is solvent, correct? This is solute. Okay, fine. Now we'll see the formula. Molarity is equal to, what is the formula for molarity? W2 M2 volume of solution, it is in ml, so we have divided by 1000. So W2 here is, we don't know. M2 is molar mass, right? Molar mass of what? Solute or solvent? 2 indicates solute. Molar mass of solute. So here solute is what? Benzoic acid. What is the formula of benzoic acid? C6H5COOH. So if we solve this, carbon, how many carbon we have? Here 7 carbon, so 7 into 12 plus 6 hydrogens are there overall, 5 plus 1, 6, 6 into 1 plus, and then 2 oxygen, 2 into 16. Okay, and if we solve this completely, now the molar mass of benzoic acid is going to be 122 gram per mole. So this is the value you are going to get. So simply what you need to do here, you need to substitute this value, 122. Volume they have given 250 ml. Okay, this is 1000, and here the molarity they have given as 0.15. So what we have to do here, we have to find out the value of W2. So if we equate this, just divide this, multiply, and By equating for W2, if you are going to solve this, the answer for this is going to be around 4.58 gram. Okay, this is going to be around 4.5. So this is a solution for this. So next, find the molarity of solution prepared by diluting 30 ml of 0. Find the molarity of solution prepared by diluting 30 ml of 0.5 molar H2SO4 solution up to 500 ml. What does it mean? We have to find the molarity. Okay. By diluting 30 ml of 0.5 molar, consider I have a solution of concentration 0.5 molar and its volume is, consider it is 30 ml. 30 ml. So volume is given as 30 ml. So if the same solution, if I add some water, its volume is going to increase, obviously. So how much water we are going to put so that its total volume is going to become 500 ml. Okay, I have diluted, I have added some water so that its volume is going to become 500. So we know that whenever we put more water, when we add more water to a solution, the volume changes and concentration also changes, right? Concentration was this before, but after adding water, it is going to change. So that, what is that concentration? What is that molarity? We need to find out. So its volume after adding a water is 500 ml. Okay. So here we are going to see one of a formula, new formula, that is M1 V1 is equal to M2 V2. So M1 is, consider this one as the first solution and this one as the second. Just we are equating this one. M1, this is M1, this is V1, this is M2 and this is V2. Simple. So just we are going to equate 0.5 into 30 equals M2 we need to find out, right? So I'll write as it is into V2 is 500. Okay, 500. And now we are going to equate this one. 0.5 into 30 divided by 500. So simply if we solve this, we are going to get an answer. The answer, that is molarity. What is the answer here we are going to get? That is 0.03 molar. Okay, simple. So let us move on to our last question. Whenever you sit to solve any of the problem, first thing you need to do is to write down the formulas of that chapter and try to remember those all. Then try to, after watching the session, what you need to do is take some more problems, try to solve by yourself. When you solve the things, you will get to know that where some students used to find difficulty in the solving numericals, especially for them. The tip is, first, whenever you start the problem, write down the given part. Then write down what you need to find. What you need to find, you must know that properly, right? So write down the given part and write down what you need to find out. And write down the formula to find out that. See, here the given part is only this one, right? And this. So the density they have given, that is 1.504 gram per ml. And one more is, what is this? By mass, it means mass percentage. Mass percentage, that is 68%. Okay, so this is. So here they have asked us to find out molarity. So if you know the molarity, before you write down the formula and move on, think of it. What are the components required to substitute in the formula of molarity? So we know that when I want to find out I will write the formula of molarity, I need a value for W2, M2 and volume of solution. These are the three components, three things which I need a value for it. So you have to think, do they have given a value for W2 here? No. Can I see anywhere? No. What do they have given a value for M2? No. What do they have given a value for volume? No. They have not given the direct value, but indirectly they have given the value for all these three. So from mass percentage, 68% by mass of aqueous solution of HNO3, 68% of HNO3. This means HNO3 in a solution, it means 68 gram of HNO3, that is concentrated HNO3 is mixed, is dissolved in, I don't know what gram of, somewhat a gram of water. Why water? Because aqueous they have to get 100 gram of solution. So if I want to get the value of this, what I should do? 100 minus 68 if I do, 100 minus 68 if I do, I'll get 32 gram of water is required. So through this I got the value of W2. Yes, W2 is this one, mass of solute. It's considered HNO3 is a solute here, right? So W2 I got the value from here. What about M2? M2 is the molar mass of HNO3, which can be easily solved. So M2 we can find out easily. Hydrogen is 1, nitrogen 14, then oxygen 3, oxygen is there, so this one into 16. If I solve this, the molar mass I will get it as 63. Okay, so molar mass is also I got, WD is also I got. I want volume of solution. So you have to think again. Simply they will not give any of the numericals. See, density. Is there any relationship between density and volume? Yes, we know that density is equal to mass by volume. If it is density of solution, then again mass of solution divided by volume of solution, right? So mass of solution I have got it from here. This is mass of solution, right? Gram, mass of solution. So 100 divided by volume of solution I don't know, but density I know. So what is the density? 1.504. So if I want to get the volume of solution, what I will do? Just divide 100 by 1.504. You are going to get the volume of solution. Volume of solution 0.54 ml. Okay, so now with all these things, what I got all these three values, that is mass of solute, molar mass of solute, volume of solution. Okay, in the next slide we will solve, because we got the value now, but the thing is we need to substitute, right? So molarity is equal to W2, M2 and volume of solution in ml 1000. This is a formula. What is W2? W2 we got it from here, 68, and M2 63. So 68 divided by 63 into 1000 divided by volume of solution. I got it from the density formula, right? So 66.5 ml. 66.5 ml. And if I solve this completely, I'm going to get the final value for molarity, that is around 16.231 molar. Okay. So this completes your numerical parts of concentration terms. Here generally molarity, molality, mole fractions, related to these terms, the numericals are very important in the board exams. Okay, so This is the numericals completely related to concentration terms, but in this particular video we are going to solve the numericals on all the colligative properties, which is very important. So if you are new to this channel, do subscribe and hit the like button if you like this video, and share with your friends so that even they can benefit with this. And if you have any doubts, any queries, or anything you want to comment, feel free to comment in the comment section. So stay curious, keep learning. Stay curious, keep learning. Thank you.